Welcome back to our Algebra 2 series. And now we're into some trigonometry in Chapter 7, and we're going to graph some special trig functions. This first one is a combination of a sine and a cosine graph, and we'd like to graph two periods of the function. Well, you can't even tell what one period of the function is because we've combined them. But what we're going to do with this problem is we're going to graph the two functions on the graph, and then we'll add the ordinates or the y values together. So for the second one, though, I'm going to use y equals negative 3 sine x, and that way I can just add the ordinates. All right, well, let's try this. We'll try with the second one, we'll put it in red, and the first one we'll put in blue, so that's the cosine 2x graph, and then the final graph we'll put in there by adding those up and working that out in black. Well, we do have what appears to be some nice grid values, and since we anticipate going up quite high here, I'm going to make each unit 1. So starting with the negative 3 sine x, that would start at the origin, and I'm going to dot this in. I know that it's going to go down to negative 3, and I think I'll go, let's see, maybe I'll go out here and call this guy 2 pi, and that way, let's see, that would be every other, so this will be negative pi. I may not be able to graph two complete periods of the function, but we'll see how it turns out. Now, if that's the case, that that's 2 pi, then this would be pi. This would be pi over 2 over here. So I'll just put in a pi. At pi over 2, we should be down here at negative 3, since that's negative 3 sine x, back up to 0, and then up to positive 3, back down to 0. Of course, that means we're going to be over here at 3, and then 0, and then down here at negative 3. All right, so I can put this graph in. This is the sine graph. That looks pretty good. It's not going to be perfect, but we'll do the best we can here. There we go. That's the first one. Now let's move on to the 2 cosine 2x graph. We notice that this one has an amplitude of 2, and this time we change the period. The period of this one is going to be 2 pi divided by 2, or just pi, which means that this graph will go up to 2, and it starts at 2, which would be up here at 0, 2. And if it has to complete one full cycle by pi, we're going to put it here at pi, and that means that down here at negative 2 when it's at pi over 2. Again, I'll alternate this again. This comes out to here and then back up to 2 pi. So this is real nice because I notice that there is a coordinated point. Let me go back 2 more over. That appears to be here, and 2 more back goes up to the top. Let me see if I did that right. Yep, that looks, oh, I think I made a mistake here. Way over here on the far side, this should be up here at 2 pi comma 2. Notice how that graph should be there, which means it's going right through the x-axis at that halfway point. And those are critical points for us because we want to be able to see that this graph, like that, and notice that it goes through the x-axis so many times, and that's very helpful because those are going to be nice values that we can plot on the graph. So when we're going to add these together, let's start with all x-axis values. Notice in the red graph, we go through the origin, and that makes this point a final point. Now let's go over to the next place we see an x-intercept is here, and so we'll go down to this spot over here. That's going to be on our final graph. The next x-intercept is here just before pi, so that's going to be another spot that we can label. Here at pi, we are going to label that one. Again, we see another spot right here, another x-intercept over here, another x-intercept here. All right, once we've got the x-intercepts done, and let me go backwards over here as well. I've got another one here, I've got another one here, and then another one there. Now it looks like there's going to be a little bit of movement going on. Let's see if we can find some other spots. So let's go down. Notice that here at pi over 2, both values are negative. One of them is -2, the other one is -3. If we add those together, we're going to be way down here at -5. Now, similarly, we see something happening where it doesn't look like we've got a spot where they're both up at a positive number. But notice here at 3 pi over 2, we have a 3 for the red graph and a -2 for the blue graph, and that puts us there at 1. And the same thing holds true right here. So I probably made a little bit of a mistake over here in that this spot, let me correct that just quickly here. There. And this spot should be maybe a little bit higher, about there. Looks like it kind of goes down just a little bit and then back up and around. So that looks pretty good. There's a spot down here as well. Okay, a very tricky graph. Now, if we look at it from far away, you can kind of see that it kind of comes up and does a little dip. So here we kind of go add these two together. We're up here somewhere. Let me see if I can find this spot. It looks like it kind of dips down, and then here we're really shooting down quickly to catch this bottom point, coming back up, and then down again, and then again we're gonna go down quickly like this. So this is a very complicated graph. You can see that it looks like it has one dip in the middle, and we're just outside of the range of where it would dip down again. And the same thing over here. It would have dipped down to this spot again right down here. But as you can see, it kind of looks like molars in a jaw. Here's the one molar is over here, and next molar's over there. They're supposed to look even. Oh, I must have made a mistake here. Yes, I did. And that's my mistake. I see it now in the graphing. Right over here, this was supposed to be 3 minus 2 there, and that should have come down just like it did in the other one over here. Very good. Okay. So there you go. That's a very difficult graph. And of course, it would be much harder if we had to go the other way. In other words, if we had to guess what a graph was. Here's a second example, right? A function that would produce the graph below. Well, let's use all of our resources to kind of figure out what this might be. One of the things that we see is that it can't be a straight trigonometric function. And oftentimes, when you take a function like this one, and you have some sort of trig function here, and you attach to that, by addition or subtraction, some other type of function. The key to this, of course, is that you've got a pi, negative pi, pi, and these 2 points are right along the graph y equals -x. So I'm going to just take a wild guess here and put a minus x right there. The second thing I notice is that the graph kind of looks like, if you were to straighten the graph out and draw that this way, it would look kind of like the bouncing graph that we saw in class before, where that was simply a sine or cosine graph that was doing this. And then it was flipped up, or taking the absolute value of that. So let's try something kind of fun. Let's try the sine of x, and let's put an absolute value around it. And the reason I'm not using cosine is because at 0, 0, that is an automatic point. In other words, I notice at 0 and at pi, the sine x does not affect the negative x graph. So that's the first suspicion that I have. All right, let's take a look at that on the graphing calculator. I went ahead and put that in. I put the negative x first, negative x plus the absolute value of sine x, and let's graph this and see what it looks like. Oh, well, it looks close. I think if we zoom into the center of that, let's take a look a little closer. Yep, that looks good. Well, let's zoom in there. Oh, it's not bouncing up. It's actually just going straight to the right. So let's think a little better about this one. We'll zoom back out and see if we can figure something out here. All right, back to our original problem. It looks like the graph is supposed to go up and then down, and if you just do this one, it just does that. So now I see that we're on the right track, but the sine x graph has to have more of an impact than the x graph does in order to get that bump to go upward. So I'm suggesting maybe we put a number in front of it, like a 2 or a 3. What if we did the absolute value of 2 sine x, or maybe a 3 sine x, minus x, and that will make a greater impact from the sine function. Let's see what happens there. Let's go back to the y, and let's just insert a, let's see, we'll insert a 2 right there. That looks good, and let's see if that helps our graph. There we go. And it looks like we've been able to take care of business there. It looks like the graph shows coming down, and then if you look at this line right here, that's our y equals x, y equals negative x line. Now we'd have to trace this. We would have to trace this one to see if that value is close to what it is on our other graph. But the nice part about this is that it has given us an approximate graph, and we learn a little bit about how we can coordinate things like uh, the linear function, like we see right here, with a trigonometric function. Okay, kind of a crazy little graph, but I wanted to show that to you as a little addition to what we've been studying in Chapter 7.